Deploying AI at scale requires a structural decision about your company's architecture, a fork in the road between two distinct systems. The first decision for a chief information officer is choosing between two distinct commercial and technical models, proprietary or open source. With a proprietary approach, you rent a black box brain managed by a tech giant. You access their intellectual property through an API and pay a variable fee for every token your employees consume. The open source approach is different. Providers publish the model's mathematical files, allowing companies to download and host them on their own hardware. While these files are free to download, running them requires high-performance computing power. This trades a variable usage fee for the fixed costs of infrastructure and cloud hosting. This choice sets the parameters for your data privacy compliance, your long-term cost curves, and the level of engineering freedom your team can exercise. Selecting an AI partner involves more than comparing benchmark scores. It is a question of where the model's data resides and how much of the underlying system you actually own. This maps deployment effort against the level of data control. Proprietary SaaS sits bottom left, lowest effort but minimal direct control. On-premises open source sits top right, maximum engineering effort yielding maximum privacy. Every business must identify exactly where its specific needs fall on this spectrum before adopting a new tool. Convenience in AI deployment often carries a hidden cost in the form of reduced operational independence. To compare these paradigms, we use an evaluation framework built on 4 strategic pillars. The first pillar is time to market. Proprietary APIs are fast. You plug in a key and start building immediately with no server maintenance required. Open source is slower to deploy because internal engineers must configure the hosting environment and manage server uptime. The second pillar we evaluate is data privacy and governance. With proprietary APIs, data travels over the internet to a third-party server. This forces you to rely on the vendor's service-level agreements to ensure your data isn't used for retraining. Open source models live entirely inside your own firewall. This architecture ensures that zero data ever leaves your company's virtual perimeter. While proprietary options win on initial speed, they require a higher level of trust in third-party data handling. Our third pillar is customization and engineering freedom. Proprietary models are restricted. You cannot modify the core brain or remove the safety filters imposed by the provider. Open source models allow you to fine-tune the system on your own data and customize behavioral guardrails without restriction. This freedom helps mitigate the risk of vendor lock-in. If your applications rely exclusively on a single provider's specialized tools, your operations are tied to their ecosystem. If that provider raises prices or suffers an outage, your corporate workflow can break. To prevent this, engineering teams should build model-agnostic software layers, allowing you to swap model providers by changing a few configuration lines. Operational resilience is maintained by treating models as interchangeable components rather than fixed dependencies. This chart shows the final pillar, the total cost of ownership at scale. Proprietary costs are low at first, but your monthly bill scales in direct proportion to every token your employees consume. High adoption leads to a linear increase in costs. Open source infrastructure has a high upfront cost, but as usage volume increases, your marginal cost per query drops. This creates a fixed cost structure regardless of how many users interact with the system. Beyond hardware, consider the legal risks of consumer-grade terms of service. These often give vendors the right to use your prompts to train their future models. Using AI without a legally binding enterprise SLA can lead to rising costs while simultaneously exposing your corporate intellectual property. Once you have weighed the strategic pillars, you must select one of 3 physical deployment architectures for the model. Architecture A is the third-party cloud API, where text travels over the public internet to an external provider. Architecture B is the virtual private cloud. You host an open model securely inside your own managed AWS or Azure environment. Architecture C is local on-premises. Physical server racks are installed inside your own building, allowing the models to run without an internet connection. The physical location of the hardware determines the final boundary of your data security. This framework matches specific corporate use cases to the corrupt architecture based on your data risk profile. Consider a marketing tool that analyzes public social media posts to track brand sentiment. Since the data is already public, there are 0 privacy risks. A proprietary cloud API is the efficient choice here to minimize development time. Now, consider an internal assistant that queries sensitive proprietary corporate data. This requires an open-source model hosted in a virtual private cloud. It balances security by keeping data inside your firm's digital walls without needing physical hardware. Finally, projects involving healthcare records, national defense, or private wealth portfolios require a different standard. These scenarios demand a local on-premises deployment. The upfront capital expense is high, but it guarantees absolute compliance through a completely offline system. The most effective AI tech stack is the one that aligns its physical architecture with the specific risk profile of its data.